Hello, in this lesson, I'm going to review chapter 9 and 10, which we talk about constructing confident interval and hypothesis test. So first, let's kind of review the confident interval. Well, this is the formula for constructing confident interval here. Note that let's look at the formula. P hat is your sample proportion, also the point estimate for P, and Z of alpha over 2 is your critical value. And critical value, and P, if I use critical value, Z of alpha over 2 times this quantity over here, we get air, right? This is your air. And confident interval we write it into lower bound, comma, upper bound once you write it. Very similarly for mean, you can do the same thing. Point estimate X bar plus or minus your air, and this is your air, where T of alpha over 2 is the critical value. Right. So let's review for hypothesis test for proportion. Well, for the one sample, we're comparing the hypothesis, the sample, to some prior knowledge. So to do that, first we need to check some sort of requirement so that make sure we can use the normal distribution. So the two requirements, the first one is sample size less than 5% of population size. This I'm checking for whether the samples are independent. Number two, I'm checking make sure the sample is normal. So to check that, we need to make sure it satisfies this condition, which is sample size times P naught, 1 minus P naught greater or equal to 10. Now the P naught here is called the prior knowledge, right? Something that you know from before. And once I check the requirement, then I move on to calculate, look for, make sure I find my sample size and P hat. Again, P hat sometimes can be found depending on the problem. Sometimes given to you. Sometimes you need to calculate it, which is X over N. And then your P naught, again, P naught is the prior knowledge that we're talking about here. Right, so three things we needed. Once I've done this, then I compute my test statistic. And then once I've done that, then I have two approaches. I could do critical value approach to compare my test statistic to the critical value. Or I can do p-value approach and compare my p-value to alpha. Right? Let's do an example from exam review. Now, this is an exam 3 review problem number 1. And this is selected from your homework 10.2 number 7. Now, for this problem, first I'm going to do a hypothesis test. And then I'm going to do a confident interval using the same problem. All right, let's read the problem. Several years ago, 41% of parents who have children in K-12 were satisfied with the quality of education the students receive. A recent poll asked 1,115 parents who have children in K-12 if they're satisfied with the quality of education. So out of the 1,115, 452 of them say that they are happy with this they're happy with the quality of education. Using alpha equal to 0.01 level of significance, and we're going to test to see whether this represent evidence that parents' attitude has changed. So we're going to perform appropriate hypothesis test to assess whether this represent evidence parent attitude toward quality education has changed. Okay, the keyword here has changed. All right. So first, let's think what we're talking about here. Notice that by the given information, I want to talk about the proportion, right? We want to talk about indicate. I want to know whether the proportion has changed. So has changed could be more than, could be less than. So this tells me that's going to be a two-tailed test, right? So I'm going to do a two-tailed test and for a proportion. So I can write down the given information. So let's write it down. Now, 41% of parents who had children in K-12, that's from several years ago. Notice that. From several years ago, we know that 41% of parents, they're happy with the quality of education from K-12. But not so 41 is from several years ago, so that's a prior knowledge. Prior knowledge is 41%, so that's your P naught. So P naught is equal to 41% or 0.41. Now our sample 1,115, so that's my sample size, n equal to 1,115. Let me write a little better. 1,115. And out of that, 452 of them say they're satisfied. So my x in this case here is 452. Right? Now x is the number of people who are satisfied with the K-12 education here. So x, now I 452. So using x over n, I can find my p hat with x over n. So 452 over 1115. And that is approximately 0.4054. I'm around to 4 digit here in computation. So I read the question and asked for proportion. I found the information, write down the given information. So let's check the requirement. There are two requirements. One is check to make sure the samples are, make sure the sample is normal or independent, right? So make sure the samples are normal and make sure the samples are independent of each other. So let's do it. So first one is I need to check independence. So that means I want to make sure n is less than 5% of population size. Let me just write less than 5.5% of population size with n. Note that my sample size here is 1,115. So 1,115, is that less than, or you can put equal to here, is that less than 5% of my population? Population here is all parents with children who are going to K-12, go through K-12. So all parents here. So reasonably, we can say that is definitely less than of all the parents with K-12 here. So the first condition is met. So I said the samples are independent. The second one I'm going to check is I need to make sure that it's normal. So to check normal, we say n times p hat times 1 minus p hat. I want to see if this is greater or equal to 10. Okay, so let's check. N is 1,115. My p hat here is 0.4054, and then times 1 minus 0.4054. Use your calculator, and that is approximately 269. So that is definitely greater than 10. So therefore, this condition is met. So therefore, we can use Z distribution, the normal distribution, to perform hypothesis tests because both requirements are met. Now, let's look at the hypothesis. So we're testing for mu. So my H naught is the proportion haven't changed, still the same. So P is equal to P naught, still remain the same, 0.41. And H1, the alternative hypothesis, I'm saying that it has changed. Okay, change meaning that it could be more, could be less. So therefore, P should be a two-tailed test. So P not equal to 0.41. And I remind myself, this is the two-tailed test. All right, so that's my hypothesis. Now let's look for my alpha. Alpha here is a level of significance, which is given to me is 0.01. All right, let's calculate our test statistic. And test statistic is given by this expression. And p hat minus p naught over square root of p naught times 1 minus p naught over n. So I can just compute that. Okay, I plug in all the information. So p hat minus p naught over the expression here, and use your calculator. Okay, so I plug it in the top. When I subtract it, I got negative 0.0046, and the denominator simplify to or calculate to 0.0147. Again, I'll keep 4 decimal place in my computation here, and then when I divide it, I got approximately negative 0.3129. Right, that's my test statistic. Now here I can use two different approaches to solve this problem. Now I can either do p-value approach and critical value approach. Now I'm going to do both approach here. So first, let's do the classical approach, which is a critical value approach. I'm doing a two-tailed test, so I'm going to draw my critical region. So, and I'm using alpha is equal to 0.01. So I need alpha over 2. Gonna give me 0.01 over 2. And that is giving me 0.005, meaning that the area in this tail is 0.005, and the area in this tail here is 0.005. And the middle, we're using the normal distribution with mean 0, standard deviation 1. And when I say critical value, I'm looking for the value that separates the top from the top 0.5%. Meaning I'm looking for, this is the critical value I'm looking for. This value here. This value separate it from the top and bottom. Now, to find a critical value, I can do the using a table, or I can use a calculator. I'm going to do a calculator approach here. Well, to do calculator, I'm going to do inverse norm. I'm going to look for the negative first. Z naught, or Z of alpha over 2 is equal to inverse norm. Here, I can do the positive, I can do the negative. If I do negative, I can enter the value as 0.005 and then flip it to get the positive. So let me do the negative here so I get both. So 0.005, that's area on the left of negative Z of alpha over 2. And then mean and standard deviation. And plug that into the calculator, we'll get negative 2.576, meaning that this value here is a negative 2.576. Again, we know the normal distribution is symmetric, so therefore the one on the right must be 2.576, and this value here, that is your those separates the critical region, right? And this is a critical value both here. So you could do either one. You could do the top one and get the bottom, or the bottom get top. It doesn't change the answer here. So again, those are the critical region, or called the rejection region. Now once I draw my critical region or the rejection region, now I compare to my test statistic. My test statistic is negative 0.3129. That is somewhere here. That's my Z naught. Note that the Z naught is not in the critical region. So therefore, it's in the blank region here in the middle. So therefore here, we do not reject H naught. Because the critical value does not fall into the critical region. Right? That would be the critical classical approach. If I want to do the p-value approach, again, I'm going to draw my graph using the test statistic, my Z naught. Now, Z naught here is equal to negative 0.3129. P-value is equal to the area on the left tail and area on the right tail, both tail, right? So, the negative should be the one on the left. Make sure it's correct. So, the negative is the one on the left. So, negative 0.3129. By symmetry, I can get to the one on the right, right? Because this is a two-tail test. Let me draw a little better. It's not symmetric here drawing. Make sure it's symmetric here, and that is 0.3129, and p-value is the total area in both tail, right? So since it's symmetric, I can find one of them and then times 2 to give me the p-value. Let me draw a little better. All right, so p-value equal to the total area in both tail. So I can do it by find one of them and then times 2. So I say p-value is equal to, I can do any one of those tails. Let's do the one on the left. 2 times probability of Z less than negative 0.3129. Again, the reason I'm times 2, because they're symmetric. I can just do one of them and then test the area in both tails to be equal to each other. All right. So using your calculator, 2 times normal CDF. Normal CDF. Now area, I'm looking at the shaded region on this, the left tail here, the left tail from negative infinity all the way up to negative 0.3129. So negative infinity represented by negative 999 and negative 0.3129, and 0.1 is my mean and standard deviation. And so use the calculator, I get approximately 0.7544. And that is my p-value. Right? P-value, let's compare that to my alpha. Alpha is equal to 0.01. Now that p-value here is definitely greater than alpha. When p-value is greater than alpha, we do not reject H naught or fail to reject H naught. So do not reject H naught. Right? So that's how you do this too. Now let me show you how to done on a calculator. I'm going to show you how to find the critical region, the critical value that separates the critical region. So we say we can use inverse norm to find a critical region here. So I could say to find critical region, which is the classical approach there. So I'm going to go to second vars and inverse norm, which is number 3. Now I'm going to enter the area on the left tail. The one I'm finding is 0.05, 0.005. And mean is 0, standard deviation is 1, that's the normal, Z. Now, plug it in. Notice that that's approximately negative 2.576. I can also find the one using the right tail using your calculator if you like. Let's review that. So this is second vars, and let's say I want to do the one on the right tail. Number 3, inverse norm. Now, if I want to do the one on the right tail, the total area on the left of the critical region on the right, which is the green one here, the total area will be from 0.009 plus the 99 in the middle. So the total area will be 0.995, which is 1 minus alpha over 2, right? This area. And if we enter that, you will get a positive critical value, which is 2.576 approximately. Notice that these two exactly the same, only difference is a different in negative in sign, right? That's how you find the critical value from the classical approach. Now to find the p-value, all right, let me clear that. P-value is second vars. We're going to look for no more CDF, which is number 2. Now, I'm going to look for the area in the lower tail. The lower tail is negative infinity, represented by negative 999. And upper bound is a negative 0.3129. And I mean the standard deviation of 1 for z here. So enter. And that is just one of the tail. Well, to get it times 2, we're going to give me the total probability here, or p-value, times 2 tail test, and that is approximately 0.7544. Right? That is the p-value. Right? So notice that that's how you find critical value and p-value. Now let's learn how to write conclusion. We rejected H0. If we rejected H0, meaning that, we do not reject H0, We do not reject H0. Let's review what our hypothesis is. Okay, let's go up to the hypothesis. We have 2 hypotheses here. Right? So when I don't reject the H0, meaning that P is still equal to 0.41. So 41% is still the same. I'm not rejecting that. All right? And so let's write the conclusion. To write a conclusion, I can say they are not enough information, not enough evidence to support the claim H1 that the parents' attitude toward quality education has changed. So let me write it. And so we say they are not enough information. You can also say they are insufficient evidence to support the claim. Now here I'm going to write it in terms of the application, H1, which is parents' attitude toward the quality education have changed at the 0.01 level of significance. And so that's how you will write a conclusion. Right, now let's gonna do the same problem. I'm gonna do construct a confidence interval. Wait, before I do the confidence interval, before we construct confidence interval, I'd like to show you how to do a hypothesis test using your calculator. To do a hypothesis using your calculator, go to stat, go to using the arrow, go to test. Now here, this is a proportion, one sample proportion. So go to one prop z test. Now that one prop z test is number 5. Using the little arrow, go down to number 5. One prop z test, enter. Now P0 is a prior knowledge, is prior information with 0.41. And my X here is 452. And my sample here, the 0.00, my sample size is 1,115, and I'm doing a 2-tail test. Okay, I'm gonna put an enter, and then calculate. Now notice that my critical value, test statistic, Z, the first number test statistic, that's negative 0.31358 here. That's a value similar to what we got over here, right? We got this value here. Notice that we're doing approximation here, so it's a little bit off. So that is your test statistic, the first one. The second one is our p-value. And this is p-hat, and that's your n. So you can always use your calculator to see and make sure that your calculation is correct. All right, now let's go to do a confidence interval. So this is the same problem here, but here only difference is I'm going to construct a 99% confidence interval to assess whether this represents evidence that the parent attitude toward quality education has changed. Right, same problem. I'm just gonna do it in hypothesis test. Let's recall our hypothesis. We say there are 2 hypotheses. One is the H1, H0, which is no hypothesis. I can say the proportion is still the same. There's no change. So 0.41, and my H1, we say has changed. Parents' attitude toward quality education has changed. We say there's a two-tailed test, right? So we can construct a confidence interval now. Note that for confidence interval, all the requirement we already check in number 1, right? The requirement for confidence interval is the same as the requirement for the hypothesis test. So the requirements are met. So all I have to do is just find the interval. Note that confidence interval given by p hat plus or minus z of alpha over 2. Notice I'm using the positive z of alpha over 2 here, and times the square root of p hat 1 minus p hat over n. Right? So now I just plug in the information. So when I plug in the information here, notice that my critical value here, I'm using the positive one from the previous one. Notice that in the previous one, for the classical approach, I have 2 critical values. One's a negative, one's a positive. For confidence interval, we always use the positive one. So type in the information and then use your calculator. In your calculator, you will calculate that this part here, the air total here is equal to 0.0379 and plus or minus to the point estimate p hat, and gonna give me and so 0.4054 minus 0.0379 gonna give me the lower bound, and when I add them I get the upper bound, and that is the confidence interval. Right, so we constructed the confidence interval here. Now let's kind of do our interpretation. So what is the correct conclusion here? Choose one. So here, let's look at here. So we look at the interval. Notice the interval does contain the null. The null hypothesis 0.41. 41, notice that 0.41 is a number between the lower bound and the upper bound. And since the interval contains the null P naught, the null, then we say there's not a significant change. We fail to reject H naught because it contains the null. So let's see which one of them actually says that, right? So you can see that D, since the interval contains the proportion stated in the null hypothesis, right? The proportion stated in the null is 0.41. There is insufficient evidence that the parents' attitude toward the quality education has changed, right? So D should be the correct solution because it contains the null. Now let's compare the answer we get in number 1 and number 2. So in number 1, both number 1 and number 2, notice that we both saying that the parents' attitude, there's not enough evidence to say that the parents' attitude has changed. So we arrive at the same conclusion. So we say both methods found that there are not enough evidence or not enough sample evidence to conclude that the parents' attitude toward the quality education has changed. So for two-tailed hypothesis test and confidence interval, here we've done both, and those arrive at the same conclusion here. Right, now let me show you how to find confidence interval using your calculator. So for confidence interval, we're gonna go same place that we're gonna go to same place where we get the test. So go to stat, go to tests. Now we're doing one proportion, so one z interval, which is number 7. So z interval, we're using the z distribution here, normal z distribution, so z interval. And we're using data. We're not using data, we're using statistics. I'm going to type in the thing here. Oh, notice that the z interval here tells me put in a sigma, which we don't know sigma. So that's the incorrect one. So 1 pop z in if I know the population standard deviation. So since I don't know that, I also use 1 pop z in. All right. So that's number A in the test. So let's enter. Now notice I'm at X. In this case, X is 452 and sample size is 1115, and the confidence interval that I want to get is the 99%. So notice here I want percentage here, and then calculate. And notice that that's the confidence interval. That's 0.3675 and versus upper bound is 0.44325. So pretty close to the number we got, right? So that's how you check your answer for confidence interval. All right. Okay, so this concludes our hypothesis test and confidence interval for proportion. All right, let me take you back to the formula page again so you can see one more. So we did the confidence interval for proportion, and we also do the hypothesis test for two-tailed test. In the next video, I'm going to do a confidence interval for mean, and then also hypothesis test for mean.